NENOMATICA, where mathematics meets YouTube excellence. Welcome to this lesson on factoring by grouping. Factoring by grouping is a powerful algebraic technique that helps us simplify complex expressions by identifying common factors within groups of terms. Let's consider the following expression: x squared plus 2x plus xy plus 2y. As you can see, when we look at this expression, none of the terms share a common factor across all of them. First, we'll rearrange these terms by grouping them in a way that makes common factors visible within each group. We'll group the first two terms together, x squared plus 2x, and the second two terms together, xy plus 2y. Now we can place parentheses around each group to make it clearer. In step 2, now, for each group, we'll factor out the common term. Light bulb tip: finding the common factor in each group is the key to this method. For the first group, x squared plus 2x, we can factor out x, giving us x times the quantity x plus 2. For the second group, now our expression looks like x times the quantity x plus 2 plus y times the quantity x plus 2. In step 3, we can see a common factor appearing between our two groups. Do you notice that x plus 2 is common in both groups? This x plus 2 is our common binomial factor. In step 4, now we can factor out this common binomial from both terms. We can rewrite our expression as the common factor x plus 2 multiplied by the sum of the remaining coefficients x plus y. So our fully factored expression is x plus y times x plus 2. Let's verify our factorization by expanding it back to confirm it equals our original expression. When we multiply x plus y and x plus 2 using the distributive property, we get x times x, which is x squared, plus x times 2, which is 2x, plus y times x, which is xy, plus y times 2, which is 2y. So we have x squared plus 2x plus xy plus 2y, which matches our original expression. This confirms our factorization is correct. Let's start with the definition. Factoring by grouping is a technique we use when all the terms in an expression don't share a common factor. First, we group the terms in the expression. Then, within each group, we factor out the common factor so that a common factor appears in the next stage. Now, let's work through an example. We'll factor the expression z cubed minus z squared minus 9z plus 9. First, let's group the terms. We'll put the first two terms together and the last two terms together. We get open parentheses, z cubed minus z squared, close parentheses, minus open parentheses, 9z minus 9, close parentheses. For the first group, we can factor out z squared, giving us z squared times open parentheses, z minus 1, close parentheses. For the second group, we can factor out 9, giving us minus 9 times open parentheses, z minus 1, close parentheses. Now, we notice that both groups have the common factor of z minus 1, so we can factor that out. This gives us open parentheses, z minus 1, close parentheses, times open parentheses, z squared minus 9, close parentheses. But we're not done yet. We can factor the expression z squared minus 9 further by recognizing it as a difference of squares. We know that a squared minus b squared equals open parentheses, a plus b close parentheses times open parentheses, a minus b close parentheses. In our case, O is z and b is 3. So z squared minus 9 equals open parentheses, z plus 3 close parentheses, times open parentheses, z minus 3 close parentheses. Therefore, our final factorization is open parentheses, z minus 1 close parentheses times open parentheses, z minus 3 close parentheses times open parentheses, z plus 3 close parentheses. Let's try another example to reinforce this concept. Here's a quick challenge for you. Try to factor the expression x squared minus x squared, y minus x plus y by grouping. Pause the video and give it a try. Let's work through it together. First, we group the terms. Open parentheses, x squared minus x close parentheses minus open parentheses, x squared, y minus y close parentheses. Next, we factor out the common factors from each group. From the first group, we can factor out x to get x times open parentheses, x minus 1 close parentheses. From the second group, we can factor out y to get minus y times open parentheses, x squared minus 1 close parentheses. Now, we notice that both groups don't yet have a common factor. Let's factor x squared minus 1 as a difference of squares. This gives us minus y times open parentheses x plus 1 close parentheses times open parentheses x minus 1 close parentheses. Now we can see that both groups have x minus 1 as a common factor. Factoring it out, we get open parentheses x minus 1 close parentheses times open parentheses x minus y times open parentheses x plus 1 close parentheses close parentheses. Let's summarize what we've learned about factoring by grouping. Factoring by grouping is a technique used when the terms in an expression don't share a common factor. The key steps are: first, we group the terms. Then, we factor out common factors from each group. Finally, we look for a common factor among the groups and factor it out. Remember that sometimes we may need to apply other factoring techniques like the difference of squares to help find common factors. Practice factoring different types of polynomials to strengthen your skills. In our next video, we'll explore factoring more complex polynomial expressions. If you have any questions, please leave them in the comments section below. We want to factor the polynomial x to the fourth plus x cubed plus x squared plus 4x plus 3. The method we'll use is called factorization by grouping. This involves organizing the terms into groups that have common factors, then factoring out those common terms. Let's begin our factorization process. The first step is to group the terms in a way that allows us to factor them effectively. For this example, we'll group the first 2 terms together and the last 3 terms together. So we have open parenthesis x to the fourth plus x cubed close parenthesis plus open parenthesis x squared plus 4x plus 3 close parenthesis. Now, let's factor out the common terms from each group. In the first group, x to the fourth plus x cubed, we can factor out x cubed, leaving us with x cubed times open parenthesis x plus 1 close parenthesis. In the second group, x squared plus 4x plus 3, we can try to find common factors or see if it's a special pattern. Looking at this polynomial, we notice it can be factored as open parenthesis x plus 1 close parenthesis times open parenthesis x plus 3 close parenthesis. So our expression becomes x cubed times open parenthesis x plus 1 close parenthesis plus open parenthesis x plus 1 close parenthesis times open parenthesis x plus 3 close parenthesis. Now we can see that both terms have a common factor of x plus 1. Let's factor this out. Open parenthesis x plus 1 close parenthesis times open bracket x cubed plus open parenthesis x plus 3 close parenthesis close bracket. Let's simplify the expression inside the square brackets. X cubed plus open parenthesis x plus 3 close parenthesis equals x cubed plus x plus 3. Now, let's look at our second example. We want to factor the expression AC plus BC plus AD plus BD. We'll use the same grouping method to factor this expression. First, let's group the terms that have common factors. We'll group the first 2 terms together because they both contain C, and the last 2 terms together because they both contain D. So we have open parenthesis AC plus BC close parenthesis plus open parenthesis AD plus BD close parenthesis. Now, let's factor out the common terms from each group. In the first group, AC plus BC, we can factor out C, leaving us with C times open parenthesis a plus B close parenthesis. In the second group, AD plus BD, we can factor out D, leaving us with D times open parenthesis a plus B close parenthesis. So our expression becomes C times open parenthesis a plus B close parenthesis plus D times open parenthesis a plus B close parenthesis. Now we can see that both terms have a common factor of a plus B. Let's factor this out. Open parenthesis a plus B close parenthesis times open parenthesis C plus D close parenthesis. Thinking phase quick challenge. Can you think of another way to group these terms to get the same result? Pause button, pause for a moment to think about it. Light bulb tip. You could also group terms with O in common and terms with B in common. An alternative grouping would be open parenthesis AC plus AD close parenthesis plus open parenthesis BC plus BD close parenthesis, which gives us a times open parenthesis C plus D close parenthesis plus B times open parenthesis C plus D close parenthesis, and finally open parenthesis a plus B close parenthesis times open parenthesis C plus D close parenthesis. White heavy checkmark. Both methods yield the same result. Open parenthesis a plus B close parenthesis times open parenthesis C plus D close parenthesis. Let's summarize what we've learned about factorization by grouping. We need to factor the expression AC minus BC plus AD minus BD. First, let's look at this expression. and think about how we can rewrite it to identify common factors. Let's start by grouping the first two terms and the last two terms. We get open parenthesis, AC minus BC close parenthesis plus open parenthesis, AD minus BD close parenthesis. Now, in the first grouping, we can factor out a common C, and in the second grouping, we can factor out a common D. Notice that we now have a common factor of a minus B in both terms. Using the distributive property again, we can factor out this common expression a minus B. So our final factored form is a minus B times the quantity C plus D. Let's visualize how the distributive property works in this problem. The expression a minus B times C plus D means we distribute a minus B to each term inside the second parenthesis. When we distribute a minus B to C, we get a C minus BC. And when we distribute a minus B to D, we get a D minus BD. When we combine these results, we get back our original expression, a C minus BC plus a D minus BD. Now, let's look at our second example. We need to factor the expression 6, ax plus 9, a y minus 4bx minus 6by. Again, let's look for patterns and common factors. Let's start by grouping the terms with similar variables. We get open parenthesis 6, ax plus 9, a y close parenthesis plus open parenthesis negative 4, bx minus 6by close parenthesis. In the first group, we can factor out 3a. In the second group, we can factor out negative 2b. Looking at what we've factored so far, we can see that 2x plus 3y is a common factor in both terms. So we can factor out 2x plus 3y from both terms. Our final answer is 2x plus 3y times the quantity 3 a minus 2b. Let's visually understand the factoring process for our second example. We start with 6ax plus 9ay minus 4bx minus 6by. First, we identify common factors in groups of terms. In the first two terms, a is common. In the last two terms, b is common. After factoring these common terms, we notice that 2x plus 3y appears in both groups. This allows us to factor out 2x plus 3y from the entire expression, giving us our final answer, 2x plus 3y times 3a minus 2b. Now, let's try a quick challenge. Try to factor the expression x, y plus xz minus 2y minus 2z on your own. Pause the video and give it a try. Hint, look for common factors and try to group the terms. The solution is x minus 2 times the quantity y plus z. Did you get it right? Great job! Let's summarize what we've learned about factoring algebraic expressions. First, look for common factors within groups of terms. Second, factor out these common factors using the distributive property. Third, look for common expressions across different groups. Fourth, factor out these common expressions to get the final factored form. Remember, practice is key. We want to factor the expression a to the 5th power minus a to the 4th power plus a cubed minus a squared. Let's approach this systematically. First, we'll use the grouping method to factor this expression. The key insight is to notice that we can group these terms into two pairs, a to the 5th minus a to the 4th, and a cubed minus a squared. Notice that in each group, we can factor out a common term. In the first group, we can factor out a to the 4th power, and in the second group, we can factor out a squared. So our expression becomes a to the 4th times a minus 1 plus a squared times a minus 1. Do you see a common factor in both terms? Yes, both terms have the factor a minus 1. Let's factor this out. We get a minus 1 multiplied by a to the 4th plus a squared. We still have a to the 4th plus a squared inside the parentheses. Notice that we can factor out a squared from this expression. So we get a minus 1 times a squared plus 1. Our fully factored expression is a minus 1 times a squared plus 1. Let's rearrange it to match the form in our example. So the factored form of a to the 5th minus a to the 4th plus a cubed minus a squared is a minus 1 times a squared plus 1. Now, let's move on to our second example. We want to factor the expression 8x minus bx plus 8i minus by. Thinking face, let's analyze this expression. We can start by grouping the terms containing similar variables. We'll group the terms with x together and the terms with y together. So we have 8x minus bx plus 8i minus by. Now, let's factor out the common terms from each group. From the first group, we can factor out x, and from the second group, we can factor out y. This gives us x times 8a minus b plus y times 8a minus b. You notice a common factor in both terms? Yes, the expression 8a minus b appears in both terms. So we can factor it out to get 8a minus b times x plus y. Let's move on to our third example. We want to factor the expression x squared plus x plus a plus bx. This expression looks a bit different. Let's try to group the terms in a way that will help us identify common factors. We'll group x squared plus x together and a plus bx together. Let's factor out the common terms from each group. From the first group, we can factor out x, and from the second group, we can factor out b. This gives us x times x plus b times a plus x. We need to look for a common factor. Notice that a plus x in the second term is the same as x plus a in the first term, just in a different order. Let's rewrite our expression to make this clearer. We get x times x plus a plus b times x plus a. Now we can clearly see that both terms have a common factor of x plus a. Let's factor this out. Our expression becomes x plus a times x plus b. Let's summarize what we've learned about algebraic factoring techniques. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.